talk about what supersonic is. So supersonic is when you go faster than the speed of sound. So faster than the sound coming out of your mouth, reaching other people's ears. A good example of this is thunder and lightning. So when you see lightning, that's traveling at the speed of light, that's near instantaneous. And then it takes a few seconds for thunder to get to you. That's traveling at the speed of sound, which is about 750 miles an hour. Now, the reason this is a big deal is because when an aircraft is going through the air, it creates pressure waves. And the faster it goes, the more these pressure waves compress. Once you go supersonic, all those pressure waves have compressed into a single high energy wave, and it can actually create damage on the ground. So the highest ever recorded sonic boom is by an F4 that was traveling at 100 feet supersonic, and it created 144 pounds of pressure per square foot. So it's not enough to blow over a house or something like that, but it is enough to shatter windows. So imagine just standing on top of a window, 144 pounds, that's probably gonna break the window. Now, a lot of people think they've seen a plane go supersonic, so they go to air shows and they see those high speed passes. They are not going supersonic, so they're going transonic. So transonic is when parts of the airflow are going supersonic over the aircraft, but the aircraft itself is not going supersonic. So you might ask, how is that possible? Well, let's look at the wing. So a wing is designed to be curved on top, flat on the bottom. So when the airflow hits the leading edge, it separates, and then the airflow needs to speed up to go over that curved area on top. So there, the air is flowing faster than the aircraft is actually traveling through the air. So bits and pieces on the aircraft will be going supersonic for a transonic pass. I heard a story from one of my friends who's a Thunderbird pilot. He was saying that they're not allowed to deploy their speed brakes above, I think it was like 0.97 Mach, because that creates small shock waves on the speed brakes and that can damage people's hearing. So back in the day, people thought it was impossible to go supersonic. The reason is because you incur a lot of drag once you're going supersonic. So you need powerful engines. You also need the aircraft to be shaped properly. And then there's a third reason called Mach tuck. So Mach tuck is something that was discovered in World War II by pilots who were approaching the speed of sound in a dive. So think of P-51 or Corsair. They're getting up to, I don't know, 0.8, 0.9, 0.95 Mach, and shock waves were starting to form on the leading edges of the control surfaces. And so these shock waves would propagate outward and it would prevent air from hitting the elevators on the aircraft. And so they would get into a dive and they would not be able to pull out of the dive, and unfortunately they would impact the ground. So what engineers did is they did something smart. They made the whole control surface move. So on like an F-16 or F-35, we don't have elevators. We have a horizontal stab. And so this whole thing moves to prevent Mach tuck. It also gives more surface area to maneuver the jet.